Our group project explored the relationship between petroleum prices and inflation trends in Malaysia. As both an oil producer and importer, Malaysia's economy is highly sensitive to fuel price fluctuation, which influence transportation costs, manufacturing, and national fiscal stability. According to research by AMRO and Malaysia's Department of Statistics, changes in oil prices can directly affect consumer price index levels and government revenue. To analyze this relationship, we apply the least square method using three regression models: linear, quadratic, and cubic. We began by assuming a direct and proportional relationship between food prices and inflation. So using the least square method, we fitted a line to the data where food prices range from 2.05 ringgit to 3 ringgit per litre, and inflation rates from 1.8% to 6.5%. The resulting equation is y equal to negative 8.4 plus 4.96x. In this context, x represents the full price in Malaysian ringgit per litre, and y is the estimated inflation rate in percent. The slope of 4.96 suggests that for every 1 ringgit increase in full price, inflation is predicted to rise by around 4.96%. This shows a strong positive correlation where rising oil costs contribute directly to higher consumer prices. To verify the model's accuracy, we calculated the error vector, measuring how far the predictions are from the actual data points. The error magnitude was approximately 0.04x6, indicating reasonably good model performance. Visually, the linear model shows a steady upward trend, capturing the general inflationary effect of food price increases. However, the error graph reveals small deviation, especially at higher price levels, suggesting inflation may not rise in a perfectly linear fashion. This leads us to ask, could inflation behave differently under extreme conditions? Would a more flexible model like quadratic or cubic give us a tighter fit? That's what we are going to explore next.
Let's continue with the quadratic model. Here is the metric representation of the quadratic model. X represents the fuel price and Y represents the inflation rate. This data was substituted into a quadratic equation. The fuel price for each observation need to be squared to get the value of x squared. Therefore, the data were written in metric form as metric M. The normal equation that we get from M transpose M equal to M transpose Y is shown on the first diagram, where the 3/3 metric times the metric V ABC equal to the 3/1 metric. To get the value of metric V ABC, we inverse the metric 3/3 and then time it with metric 3/1. Then the value of metric V ABC will be obtained, and we can substitute this value into the quadratic formula, where Y is equal to A plus BX plus CX squared. So, the best fit quadratic curve is y equal to negative 7.26 plus 4.04x plus 0.18x squared. Next is to find the error vector. The formula is the error vector is equal to metric y minus metric MV. Since we already figured out the value of metric V using the least square method, the metric of MV was obtained by multiplying metric M with metric V. The error vector was obtained as shown here, and then by using Maple software, the error magnitude was calculated to get the value 0.0456, which may be the best approximation between the other two models. On the left side is the graph showing the best fit curve represent a quadratic model where y is equal to negative 7.26 plus 4.04x plus 0.18x squared. On the right side is the graph of the error vector against the x value of the quadratic model.
So for the next slide, my name is Muhammad Nazib Muhammad Nizam. I will explain how we run least square method by using a cubic model. So as for cubic model, the equation is y equals to a plus bx plus cx squared plus dx cubed. So as for cubic model, we using a maple, we gain a normal equation from this model. So from the normal equation, we implies the least square method. As a result, we gain the best fit curve of this cubic model, which is y equals to negative 2.540 minus 1. So in order for us to check the significance between these two variables, which is fuel price and inflation rate, we check the error magnitude of this cubic model. So as a result, the value is 0.0934, less than 0.05, shows a best fit curve for this model, and it shows that inflation rate explains all the values on the fuel price. So last but not least, the figure shows the graph of the best fit cubic model from equation y equals to negative 2.40 minus 1.6785x plus 2.431x squared minus 0.3011x cubed. So from the graph, you can see that at the minimum price of the fuel price, when the price is slightly increased, it leads to the increase of the inflation rates. So it explains the fuel price has affected the inflation rate in Malaysia. Therefore, after we run a least square method for three types of models such as linear model, cubic model and quadratic model, we can conclude that the best fit curve in this case is cubic model, since it has the minimum errors in terms of its magnitude, which is 0.0395. It explains all the variables in the equation model.